So in this video we will define the filter and we will also discuss some example. That means we'll discuss the definition of filter and we'll also discuss some examples. What is filter? Filter is a collection of subset of a non-empty set X which will satisfy some properties. So if we consider a non-empty set X, so for definition, if let X be a non-empty set, that means it cannot be empty set, non-empty set, then a collection which is denoted by F, because for filter first letter is F, of subsets of X is called a filter on X, a filter on X if it has the following property. If it has the following properties, it has to have three properties, following properties. So what are the properties? The first property is, the empty set cannot be in that collection F. Okay, empty set cannot be in that collection, but the whole set X should be in F. Okay, for the definition of algebra, sigma algebra, the both empty set and the whole set was in that collection, but for filter, empty set cannot be in that collection, but X would be in that collection. Now second property is, if there are two subsets A, B, which is in that collection F, then their intersection also would be in that collection. Okay, so if there are two sets, then their intersection also would be in that collection. This is also called like downward directed, the intersection. And the third property is, if a element of F and a subset of B, if a element of F and a subset of B, then B also would be element of F. Okay. This is also called upward closed. This property is called upward closed. So if there is a set A which is in the collection and A is a subset of another set B, then B should be in that collection. Okay. Now we can discuss some example. So to discuss example, we need to consider non-empty set X. So let X is a non-empty set which has three elements, 1, 2, 3. Then first one, the collection F, which is 1, 2 and the whole set, or we can write this way, the whole set and 1, 2, because empty set cannot be in that collection. So empty set is not in the collection, is a filter on X. Okay. Now it satisfies all of the three properties. So first property, it satisfies because empty set is not here but the whole set is here. Now if A be element of F, then the intersection should be in that collection. So here are two sets, X and 1, 2. So what is the intersection? The intersection is 1 2 3 and 1 2, their intersection is 1 2, right? So this is also here. Now here the third property, if a element of F and a subset of B, then B should be in F. So here 1 2 is subset of X, right? 1 2 subset of X and X also in that collection. So it satisfies all of the three properties. That's why it's a filter. Now second example, if we consider F equals to the whole set, then 1 2 and 1 3, then this is also a filter, is a filter on the set X. Why? Because it satisfies the first property. The empty set is not here, but the whole set is here. Now how about the second property? If you consider any two subset 1 and 1 2, so what is the intersection? Intersection is 1 and 1 is already here, so it satisfies the second property. If you consider 1 2 and 1 3, their intersection is 1 is also here. And how about the third property? If A subset of B, and so we can think this one subset of 1 2 and 1 2 also here. Okay, so it satisfies all of the three properties. That's why it's a filter. Now for third example, if we consider F equals to the whole set, then 1 2, then 2 3, this is not a filter, is not a filter on X. Why it is not a filter? It satisfies the first property. Okay, it satisfies first property. How about the second property? If you consider two subsets, suppose this one and that one, if you consider these two, then their intersection should be in that collection. What is their intersection? 1 2 and 2 3, their intersection is 2, right? Because 2 element is common, but 2 is not in that collection, so it doesn't satisfy the second property. That's why it is not a filter. Since it doesn't satisfy second property, we do not need to check third one. Okay, because to be a filter, it has to satisfy all of the three properties. Now let's consider another example. F equals to the whole set X, then 1 2, 1, then 2 and 1 2. So this is not a filter, is not a filter on X. Why? It satisfies the first property. Now how about the second property? It also satisfies third property, because if A subset of B, so 1 subset of 1 2 and 1 2 is also in that collection, 2 subset of 1 2 and 1 2 also in that collection. But there's a problem here. If you consider 1 and 2, so what is the intersection? The intersection is empty set, right? The intersection is empty set. But by the definition of filter, empty set should not be in that collection. So there intersection is empty set and empty set is not here, so it actually cannot be here. That's why it is not a filter. How about this one? Now if you consider F equals to the whole set X, then empty set, then 1 and 1 2, is it a filter? No, it is not a filter. It is not a filter on X, because it doesn't satisfy the first property. According to the first property, the empty set cannot be in that collection, so it fails to satisfy first property. That's why it is not a filter. Now, last example, if we consider the whole set, this is also a filter on X, because it satisfies all of the three properties. So empty set is not here, there is only one element, so it is also here. So it satisfies all of the three properties, that's why it is also a filter. Thanks for watching.